Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at Lesson 7.7, Factoring Special Products. We're going to be looking for 9 things to go on our notes today, so let's go ahead and get started. The first thing we want to make sure we still understand is the difference of two squares pattern. So if you have a squared minus b squared, that just represents the factored version of a plus b times a minus b. And another example you could see would be x squared minus 9. You're essentially just trying to find the square root of x squared and the square root of 9. The square root of x squared is x, and the square root of 9 is 3. So that means one example, or one foiled, or one factored binomial would be x plus 3, and the other one would be x minus 3. I would go ahead and take the time now to pause and write these two examples down, and then once you're done, click play so you can see how it's done. So these we're just going to try real quick, and then I'm going to get you to try some on your own. These are perfect squares. X squared has a square root of x, so what I can do is just write x, and then 25 has a square root of 5, so my answer will be x plus 5 times x minus 5. Sometimes you might have a coefficient with a variable, but as long as the coefficient has a perfect square, you can also find the square root of it. The square root of 4z squared is going to be 2z, and the square root of 1 is just 1. So my answer for letter B would be 2z plus 1 times 2z minus 1. Now we're going to go ahead and try some on our own. So this is 2, 3, and 4 in your notes. Let's go ahead and pause the video now so you can try them, and then once you're done, click play to check your work. Alright, so these should be pretty easy by now that you've seen and kind of gotten the hang of it. Number 2 was x plus 6 times x minus 6. Number 3, you just flipped them around. It'd be 10 plus m times 10 minus m. And then number 4 would be 3n plus 4 times 3n minus 4. Okay? The next thing we're going to talk about is whenever we have two numbers, you're still going to use that same rule of the perfect square. So if I have 54 squared minus 48 squared, that just means I'm going to do 54 minus 48, because that's the square root of 54 squared and 48 squared, and then 54 plus 48. And then it just becomes a matter of just solving it like normal numbers. 54 minus 48 is 6, and 54 plus 48 is 102. Yep, so just add those together. So I'm basically just multiplying 6 times 102, and I'm going to get 612, and that's all you have to do there. So just all you're going to do is just show the differences, the 54 minus 48, 54 plus 48, solve each parentheses separately, and then multiply to find your answer. So here are 3 that you are going to try. Again, use that same pattern you did in questions 2 through 4, except now you actually have some numbers to deal with. Let's go ahead and pause so we can try it, and once you're done, click play to check your work. So number 5, you should have done 36 plus 34 times 36 minus 34. 36 plus 34 is 70. 36 minus 34 is 2, and 70 times 2 is 140. For number 6, we have 47 plus 44 times 47 minus 44. 47 plus 44 will give us 91, and 47 minus 44 gives us 3. Multiplying 91 and 3 together, we get 273. And then number 7, we would have 55 plus 50 times 55 minus 50. That's going to be 105 times 5, which is 525. There we go. The last thing we're going to see is whenever we factor a polynomial, and we're going to have essentially a squared answer. So we would factor this polynomial just like we learned a few lessons ago. We would find the product of 16 times n, or 16 times 1. That's going to give me 16. I also want to do something plus something to give me 8 while still using the product of 16. I know that I can do, or still using, yeah, still having the product of 16. I know that I can do I know I could do 4 plus 4 to give me 8. So that means 4 times 4 is also going to give me that 16. So my two factors I'm going to split for the 8n will be 4 and 4. So I'm going to have n squared plus 4n plus 4n plus 16. And then I'm going to factor by grouping. So n squared plus 4n have n in common. So that'd be n plus 2n. And then over here, they have 4 in common. So that'd be n plus 4. And I made a mistake because I realized my numbers weren't matching up. For this first one, if I took out an n, it'd be n plus 4 as well. Noticing too, I had matching binomials. That's part 1 of my answer. And then I used the other two to write my second answer, and that would also be n plus 4. So what I would end up writing my answer as is n plus 4 squared, because there's 2 of them. Okay, so we're going to try these last 2 in our notes. Again, your answer should end up having where you're going to have a squared binomial. That's the same thing. So let's go ahead and pause so we can try 8 and 9, and then once you're done, click play. All right, so for number 8, if I multiply d times 25, I'm going to get 25. And I need to also make negative 10 with those factors, so I'm going to use negative 5 and negative 5. So I'm going to have d squared minus 5d minus 5d plus 25. Then I'm going to go ahead and combine, or by grouping. The first one I'm going to factor out d, so I'll have d minus 5. And then the second one I'm going to factor out negative 5. So that means I would have d minus 5 again. My two matching binomials are d minus 5s. And then my two leftovers are also d minus 5. So my answer is d minus 5 squared. For number 9, that one was a little bit trickier if you ended up trying it. If you got frustrated, that's okay. What I did first, because I have 9 times 36, I really didn't want to find the factors of 324 that would also add up to 36. So what I did is I actually factored out the 9 first to give me z squared plus 4z plus 4. Then that made that a little bit easier to go by grouping and to find my matching binomial. Z squared times, or 1 times 4 is 4. And so basically I just need to find what times what will also give me 4. That would also add to 2, and that would be 2 plus 2. So z squared, I'm going to make my z's a little bit clearer because my 2's kind of look like z's as well, plus 2z plus 2z plus 4. So now I'm just going to factor by grouping. I'm still going to remember my 9 at the end. This first one, I can factor out a z. So I'm going to have z plus 2. And the second one, I can factor out a positive 2. So I'll have z plus 2 again. So notice again, I have z plus 2's as my matching binomial and z plus 2 as my other part of my answer, which means I will have z plus 2 squared, but then I would also need to include that 9 that I factored out. So what I'm going to do is bring that down and just put it on the outside of my binomial. Okay? So again, if the numbers are too big and you can factor out a GCF first, always try to factor out the GCF first and then factor by grouping. That's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.